Well, our question is that advantages and disadvantages of the frequency modulation over the amplitude modulation. So earlier we have discussed about the modulation, the amplitude modulation and the frequency modulations. And now we have to go through the uses and disadvantages, advantages and disadvantages of the frequency modulation over the amplitude modulation. That is, frequency modulation is superior as compared to amplitude modulation, because in amplitude modulation we have gone through it, there are certain defects. However, it is also adopted in many cases, but frequency modulation is a priority. Now, first of all, we proceed with the advantage of the frequency modulation over the amplitude modulation. The FM transmission is highly efficient because this type of transmission is in the form of pulses, so it is basically a digital communication. Here we don't adopt the analog system, so that's why it is a very effective one, and it is very fast also. So highly efficient because all the transmitted power is useful, but in amplitude modulation, the transmission, most of the power goes waste in transmitting the carrier alone. So that is, in the transducer, we find that some energy losses are there. So basically, FM transmission is faster as compared to AM transmission. Second thing is the amplitude remains constant in FM, but in we can say the amplitude modulation, the amplitude varies. So since amplitude remains constant in FM, so amplitude limiters can be used to reduce the noise in FM. So during the FM broadcast or FM communication, we find that noise is very effectively reduced, and during receiving the frequency, we don't find any significant noise. Then comes number 3, that is, depth of the amplitude modulation cannot be increased. That is, we are not in position to increase the amplitude modulation beyond 100%. However, it is very effective, that 100% amplitude modulation, but we require more than that without causing distortion. So there is no such limit in FM. Hence, noise in FM can be reduced further by increasing the deviation in frequency. So that's why we find that frequency modulation is better as compared to amplitude modulation. In frequency modulation, the standard frequency allocation provides a guard band between the commercial FM stations. When we say commercial FM stations, we are referring to the radio stations. Radio station means where radiations are transmitted. This reduces the adjacent channel interference. So in FM transmission, the adjacent channels, they don't interfere with the transmitted frequencies. In FM, the space wave propagation is used. The space wave propagation, that is called very high frequency propagation. So its radius of operation is slightly more than the line of sight. So when we say the amplitude modulation, that is generally done in the line of sight, it makes possible to operate several transmitters in the same frequency range with a negligible interference. Now, here in the sixth concept, we are using VHF and UHF. VHF stands for very high frequency, and UHF stands for ultra high frequency. So in very high frequency or ultra high frequency bands, where frequency modulation operates, there is less noise than in high frequency and medium frequency bands. So basically the purpose of frequency modulation is better, that we have to reduce the noise. So in the amplitude modulation, we find that the noise is also interrupting the whole phenomena, but in the frequency modulation, we don't find noise, and noise can be reduced to a very, very large extent, and at the receiving end, we don't find any noise in the signal. FM transmission gives high fidelity reception due to the presence of the large number of side bands. So what exactly we mean by large number of sidebands? That is larger number of frequencies which are responding to the frequency modulation. Now, disadvantages of the frequency modulation over amplitude modulation. So there are some negative points in the frequency modulation, and that is comparable to amplitude modulation. The channel required in FM is about 10 times wider than that in AM. So when 10 times wider, it means some frequencies can possibly mix up together. FM receivers and transmitters are very complex and costly. So economy is involved. So receiver and transmitters are extremely costly. FM reception, that is receiving end, is limited to line of sight. So its area of reception is much smaller than that of the amplitude modulation. In amplitude, the displacement of the wave is very wide, whereas in FM, because it is a digital propagation or it is a digital communication, so it covers a very small area. Now, our next question is related to pulse modulation with the help of suitable diagram. We have to describe the various types of the pulse modulation. So, pulse is referring to a very small wavelength or very high frequency. So, pulse modulation means that is the modulation is mixing of the signal, and the pulse modulation, those mixed signals are transmitted in the form of pulses, very small pulses. That is the wavelength will be very small. So this is very clear from a suitable diagram. So what basically is the pulse modulation? It is very clear from this is the right side figure. Number one, right from the top, unmodulated pulse is indicated. There is no modulation done there, no mixing. Then next signal is indicated, that is the modulating signal. The modulating signal means the two signals are mixed together and they are communicated in the form of alternating current pattern. Then comes PAM, that is the pulse amplitude modulation. That is, the pulse is amplified. That is, pulse modulation means, pulse amplitude modulation means that it is defined as a process in which amplitudes of the regularly spaced rectangular pulses vary in direct proportion to the instantaneous voltage of the continuous message signal. That is indicated in the second diagram. Then we come forward, that is further PAM, single polarity. When we use the term polarity, we are referring to the positive and the negative sign. And the next figure is PDM or PWM. So these are the different types of the pulse modulations. And first we have discussed only PAM, that is the pulse amplitude modulation. And the next one is pulse duration modulation. So wherever PDM is referred, it is the pulse duration. So time is controlled. It is the time-bound modulation. Here the starting time and amplitude of each pulse are constant, but the width or the duration of each pulse is made proportional to the instantaneous value of the analog signal. Earlier we have discussed about the analog signal and the digital signals. So instantaneous means at a specific instant of time. Now pulse position modulation, that is the PPM. So that is clear from the figure. Here the position of pulse relative to its unmodulated time. Unmodulated means when the mixing of the signals are not done that time. At that time of occurrence is varied in accordance with the instantaneous value of the message signal. Now pulse code modulation, that is the PCM, it is a digital process. So it means pulses move in the form of digital way, that is digital signals are made to propagate. So it is digital process in which the message signal is sampled and the amplitude of each sample is rounded off to nearest value of the finite set of allowable values, and rounded values are coded. That is, we put the code, and code will be like some color codes are there. The signals are transmitted as a binary code. The binary code will be in the form of 0 and 1.